Hello, and thank you for joining us today as we are discussing Breaking the Mold, NOARK Circuit Breaker Spring Showcase with special guest STA boxes. I will not try to say it in French. In today's session, we're going to take a close look at the latest circuit protection technologies and how they're shaping the future of electrical safety and reliability. From machine control panels to critical building infrastructure, circuit breakers play a vital role in preventing overloads, short circuits, and costly downtime. As we walk through the session today, you will learn what sets NOARK circuit breakers apart and their commitment to exceeding industry safety standards. We'll go through real-world applications with STA boxes who will share insights into how NOARK's MCCBs keep public and private sector generators running safely and efficiently. Today we have a great lineup of experts with us. We have Rob Farrell, the Director of R&D from NOARK. We have Kunmi Odonoku, who is the Technical Product Manager for NOARK. And we have Carrie-Ann Santamor, the Vice President of STA Boxes. And each of them will be walking you through some various sections today. Before we jump into things, just a very quick note on some of the admin tasks. If you look on your screen, you will all see there is a control panel there. We do please ask that you ask questions throughout the presentation. Now, the panel is here to provide that expert insight, so please don't be afraid to ask questions either in the chat or the questions box, and we'll be happy to get to those either during the presentation or at the end. We will also be recording today, so we will be sharing the video with everyone after the fact, so rest assured that you will be able to have access to all of this vital information after the presentation is done. And now, without any further ado, I would like to step aside and let the experts take over. So Rob, over to you.
Thanks, Owen. It's a pleasure to be here today. Kunmi, if you could move the next slide on, please. Yeah. So my role today is to really give everyone an overview of the company and what our focus is and really who we are. So NOARK is the company that we represent. The company was founded in 2007 and is really intended to be the North American brand for our parent corporation, which is called Chint Global. Overall, Chint is a $22 billion company, 50,000 employees worldwide. We operate in 140 countries. And Chint is the largest electrical products manufacturer in Asia and has been around since 1984. So we've got a long history in the electrical products business. And outside of North America, it's a very well recognized name. On the NOARK side, we have headquarters in Shanghai, in Los Angeles, and in Prague. So the NOARK brand is prevalent in Europe as well, as it's the premier brand for us in that market. Our business consists of, it's an expanding business consisting of low voltage circuit breakers, from miniature circuit breakers all the way through to large power breakers, low voltage power distribution, which you're going to see some of today with the enclosed products, but we're also moving into other assembled products like panel boards and switchboards. So you'll see those products coming through in the next few months. And then in addition to the low voltage products, we also are representing the Chint brand medium voltage and high voltage transformers for both pad mounts and transmission and distribution. Next slide, please. The company is very strong on research and development, and just to give you a bit of an aside, my role that I'm currently in was created at the end of last year. And in order to address the growing global presence of the company, a decision was made to create 6 regional research and development organizations. And that's what I'm heading up today. And our goal is really to provide the local certification, product, and market knowledge that's required for us to be successful in the markets outside of Asia. Supporting the R&D effort, you know, on the low voltage R&D side, there's something like 1,000 engineers employed. So it's a very large organization with plenty of depth and knowledge on low voltage products. In addition to that, in the last couple of years, we've introduced what I would call a world-class R&D lab at our headquarters in Shanghai. I've been toured through that lab 2 or 3 times in the last couple of years, and I honestly believe that it's the best equipped lab for our low voltage products anywhere in the world. 150 kA short circuit capability at 480 volts, 100 kA at 600 volts. There's an anechoic chamber for RFI and EMI testing. We can test for thermal up to 10,000 amps. And then all of the environmental testing that you could imagine is available there as well. And this lab is also accredited for UL, CSA, and by many of the other global testing agencies. So very well equipped and capable research and development organization. Next slide, please, Kumi. Moving on to the manufacturing facilities. Again, this is a world-class manufacturing organization. All of our factories are ISO 9000 certified and have obtained the ISO TS 16949, which is an additional level of quality management that's more recognized in automotive and other industries. All of our factories are driven by TQM lean practices, and automation is very prevalent in many of these factories as well. Again, a world-class manufacturing organization. Next slide, please. So then getting back to what the NOARK business here in North America offers, we've made the investment in warehouses. So we have our headquarters warehouse in California. We have a warehouse in Kitchener, Ontario, which is where I'm presenting from today. And we have another smaller one in Houston. And the aim of having these warehouses is to ensure that we're meeting the requirements for stock availability and fast deliveries. And unlike many others, we've not encountered substantial supply chain disruptions, and our products have remained available even through the worst of the pandemic and the sort of the follow-on crises. Yeah, okay, and then the last point here about our warehouses is we've implemented what we call mod centers. So the photo in the bottom right-hand corner is our air circuit breaker mod center in action in the Pomona warehouse. And we call this late point definition. So we bring in breaker frames that are substantially completed, and then in the mod center, we add the trip units and accessories that turn them into the exact model that a customer would require. The advantage of that is our delivery lead times are very fast. In a world where most air circuit breakers are taking 4 to 6 weeks or more to deliver, we can turn out 1 or 2 in a week if need be. So that's a very much a popular program for us is making these breakers very quickly. Similar kind of approach for the enclosed circuit breakers. The photo on the bottom left you see is me with a prototype of our 1200 amp enclosed breaker that we've been working on getting through UL and CSA. Yeah, I think that's it for the warehouses. Next, please, Kunmi.
I think that's all about the introduction, Rob.
Yeah, yeah. So the tagline that you see on the screen right now, this is kind of the conclusion of my part. Excellent products, exceptional value. This is what we do. We build high quality products from world-class facilities, and we can deliver them at competitive prices anywhere in North America. And that's it for me. Thanks, Kumi.
Yeah. Thank you, Rob. Just to welcome everybody once again to the webinar. So I'm just going to go into this section, which is getting to tell you about NOARK circuit breaker. But before I do that, I'd like to give you a little bit of background to what circuit breakers are and why we use them, and just to get into a little bit of the technology around circuit breakers, and then we'll talk about NOARK's offering when it comes to circuit breaker. So I'm going to start by what the definition is of a circuit breaker. So a circuit breaker is just an electrical switching device, that is used to protect an electric circuit from overcurrent situation. And we have different types of overcurrent situations. So something like an overload is an example of a current. A short circuit also is an example of an overcurrent situation. So this is a basic function of a circuit breaker to be able to detect. So the first thing is you're going to be able to sense when there is those abnormal condition, and then it's going to give a trip signal, and then make sure that the circuit is disconnected. So that's the primary function of a circuit breaker. So from the definition of a circuit breaker, you find that a circuit breaker should be able to also work under normal conditions. So we've talked about an abnormal condition. So basically, a circuit breaker should be able to carry current. It should be able to also maintain current, and then it should be able to finally interrupt current, basically. So under normal and also abnormal condition. And if you look just around here, just trying to explain that, primarily a circuit breaker is meant to protect the interconnecting conductors, in a power system. So, and we have two types of conductors. You have the feeder circuit conductor and also the branch circuit conductor. And to my left here is just an explanation of what a feeder circuit looks like and what a branch circuit looks like. So a feeder circuit is that circuit that takes power from the mains, whether from the meter or from the mains panel, and then distribute it to a different section of the power distribution. That's what you call a feeder circuit. And it will contain feeder conductors. Those are the conductors that are used here. And then you have the branch circuit conductors, which are the conductors that takes power to the load. So below here you have what you call the branch circuit breaker, and then any conductor that falls below that is what we refer to as a branch circuit conductor. And here you have the feeder circuit conductors here, while you have the conductors for the branch circuit just below that gets to the breaker. So that's like a basic introduction to what a circuit breaker is. And just to my right here, I've got an illustration of the different types of short circuit that you can find in the electrical system. A short circuit is when you have two phases of, or it could be two or more phases of electrical supply, being in contact with each other. So what happens in that moment is that it's going to create a short circuit, basically zero or a zero resistance, so that there is there is no limit to the amount of current that can be dumped on that circuit or on that system. And typically you have what we call the line to line. That's two phases coming in touch with each other. You can have line to earth. You can also have two phase with the line coming together, or you can have a three-phase symmetrical bolted fault. And of all these types of short circuit, the one that that as the least common is the three-phase bolted fault, and it's also the most deadly. So majority of the short circuit fault you will find is typically between the line to line or line to earth, and it could sometimes it could also the short circuit can be as a result of people dropping objects like conductors in between two phases. So maybe a maintenance worker dropping some kind of tool, and it causes a bridge between two phases. But basically you find more of those faults with what I just listed in the first three, and the fourth one is the least common type of short circuit fault, which is also the deadliest anyway, and it causes the most damage. The other thing to mention here is the overload, which is a system that detects overcurrent in an electrically undamaged circuit. So for example, if you have a receptacle and then it maybe is rated at 10 amps and you're loading it with like 12 amps, 13 amps, something like that, it's going to cause a slow rise in the temperature around the conducting part of the breaker. And so if it gets to a particular threshold, then it's going to cause a trigger. So basically it's an inverse time function. So it's a function of time, and it's a function of how long the circuit is exposed to that overcurrent, because it's a small amount over the rated current. So the longer it's exposed to it, then the quicker that you're going to get a trip on the circuit breaker. So I've said before, now I want to talk about some key selection parameters when you're trying to when we're talking about circuit breaker. I said earlier on that it's important that your circuit breaker should be able to carry and interrupt current both under normal and abnormal conditions. So what are the factors you want to consider before you select a circuit breaker? The first thing is, under normal condition, you need to know what is the operational voltage. At what voltage are we going to be using this circuit breaker? The other thing you want to find out, or you need to know, is what is the operational current, right, for the circuit breaker. Also, you want to find out what is the operational temperature, the operating temperature for that. And then, of course, any other product-specific parameter, something like altitude rating, because, for every product, you have specific like altitude rating. There's also the humidity rating as well, what kind of environmental condition can you expose the breaker to. So these are all like, parameters that you must bear in mind when you're trying to select a circuit breaker. So if, for example, your system voltage is 600 volts, so you should be looking out for a circuit breaker that has that rating up to 600 volt, right? If it's 480 volts, you need to do the same. You need to find what, you make sure that the specific circuit breaker you're selecting has that correct rating. Same with the current, the rated current, which is a function of the load, right? The load requirement. What's the summation of the load requirement for that facility or for that system, and that guides you on what the operational current or what the rated current should be. The other thing to look out for is the abnormal condition, right? So here it's important to know what is the interrupting rating. So we define the interrupting rating of a circuit breaker as the maximum short circuit current that the breaker can safely interrupt without damage to itself, right? So it's the amount of fault current that the breaker can safely interrupt. So that is an important parameter when you're trying to select a circuit breaker. You need to make sure that you know what that value is, and typically it comes from the design. So when the engineers are designing the system, they're going to do something what we call the fault level analysis, where they find out what at every level of installation in the system, what is the fault level. So, and it's rated in kiloamps, right? So because it's in thousands of amps. So when you find what that fault current is, then you make sure that your circuit breaker is at least equal or more than that fault current. The other parameter is the withstand rating, and this one I'll talk a little bit more about it later in later slides. Basically, it's the ability of the circuit breaker to withstand a fault within a limited time, within a limited amount of time. So it's not going to withstand the fault continuously, but it can stay for a few cycles before it then goes into the trip mode. The other thing is the making capacity. That's just the ability of the breaker to close the circuit, right? And then you have all the product specific parameters. The other thing you want to look out for when you are trying to select a circuit breaker is the life expectancy. So the mechanical life is the life, without the load connected. And then you have the electrical life, which is when you have the load connected. And these values typically are not the same. So you need to watch out for that also in the technical specification, because that determines, the longevity for the circuit breaker. And then, of course, the other parameter that you want to look out for is the accessories, the type of accessories that are available for you, because the circuit breaker should be able to do some remote control. It should be able to do some other kind of monitoring and measurement, and all kinds of accessories should be available for you to do all of those things. So basically, you're going to have electrical accessories, mechanical accessories, all kinds of accessories. So you want to also watch out for that, because typically a circuit breaker should be able to have the ability to adapt to the customer specific application. Okay. So now talking about the construction of a circuit breaker, I'm just going to go through this very quickly just to show you, like, this is a section of the circuit breaker, the inside, the component. So on the left side, I've got the miniature circuit breaker, which is smaller compared to the molded case breaker. For the purpose of this presentation, I'm just showing these two components just for us to go through the components and how it's done. So you basically have the indicator here, which tells you the status of the breaker. The toggle is what you use in controlling. So you can either close or open the contact using the toggle. The toggle also has a middle position, which is the test, which is a trip position. Basically, when there is a trip, it goes into the middle position. And then you have the coil, which is responsible for the short circuit sensing, to be able to sense the short circuit, and then cause a trip to happen. Then we have also the bimetallic part, which takes care of the overload situation. So basically, it's two metals that have two different linear expansivity coefficients. So they expand at different rates. And so what will happen is that when the circuits start experiencing overload, then it's going to eat up. But because the two metals lying on, close to each other or touching each other don't have the same linear expansivity, one is going to expand faster than the other. So it's going to make like a kind of an arc or a curvature. And so that expansion is what causes the trip mechanism on the breaker to be triggered, and then you're going to have a trip. But because it's a bimetal and it takes time to actually build up the temperature, so it takes a longer while. Then we have the contact. This is an important part of it, where you have the moving and the fixed contact. So that's where you have the connection between the load side and the line side of the circuit. So that's where you have the actual connection, the contact that is maintained, or in the contact that is made, maintained, or interrupted. And on the right side is similar to the construction of a molded case is similar. It's just that it's a bigger device, and so it has more structural stability because it uses a molded case. And then you've got the same kind of component inside, but I'd like to talk more about the arc chamber. So the arc chamber is where the arcs that are formed whenever the breaker is trying to open the contact, whether in the normal situation or an abnormal condition. You're gonna have what we call an arc. An arc is so basically when the contacts are trying to separate because of the voltage involved and the current, you find out that the current will still want to continue flowing, but the contacts are already separated. So what's gonna happen is that it's gonna try to flow through the air, causes so it's going to basically ionize the air, turn the air into like a conducting part, and so that process is what forms what we call the arc. So it can generate a substantial amount of energy, and so that energy needs to be dissipated. So the arc that's where the breaker is able to break up the arc into smaller pieces and then dissipate them so safely. When it comes to an abnormal condition, in an abnormal situation, that process needs to be fast enough to contain the amount of arc that is being generated as a result of the trip. So that's an important component inside of the circuit breaker. So I'm going to move on to talk about the NOARK circuit breaker in electrical system. So so we've got all of this lineup of products that are situated in the electrical system. And to my far most left is the UL 1066 power circuit breaker. Today we have an offering up to 4,000 amps, both for fixed and draw out. They are stored energy closed type of breaker, so it uses this spring start energy to be able to close the breaker. Just because the frame is larger, so a toggle operation might be difficult here compared to a molded case that you have a toggle. So this stored energy close is what allows you to be able to close the breaker in a smooth and effective way. It's also electronic trip, and then it's a 30-cycle short time withstand. So basically what we're saying here is that this air circuit breaker can withstand 30 cycles before, you know, that's the maximum of cycles that it can withstand in an electrical situation. So a cycle is just the time it takes for the voltage or the current to come from the positive half cycle all the way to the negative half cycle. So that's one cycle. And because in North America, we use 60 hertz for transmission. So that is roughly about 16.7 milliseconds for one cycle. So if we say that the air circuit breaker can withstand 30 cycles, that means that you're multiplying that by 16.7 milliseconds, and that gives you roughly about 500 milliseconds, which is still less than half of a second. So we're saying that for half of a second, so the breaker is able to withstand the particular current withstand rating that has been tested for. So and this is important because when you start designing system, you don't want your main breaker, which are the ones that are situated in the main switchboard, to react first to any fault. So you need this withstand rating in order for it to, so almost like you can delay the reaction of the main circuit breaker and allow all the other breakers downstream in the feeder circuit or in the branch circuit to react first to the fault. So that's the importance of the withstand rating. And if you look at the molded case breaker here, it's a 3-cycle short time withstand. So it does not have the ability to withstand the fault for a longer time. So essentially, you don't want to use this, depending on the design of your system. You don't want it to be at the main incoming of your system because it has a shorter short time withstand. If you have it in that kind of design, what it means is that while the downstream breaker are trying to react to a fault, your your main breaker also is going to be reacting at the same time. And what it means is that you can have a downtime here, because if the main breaker is off and you have other feeders or other LD feeders in the system, because the main breaker is off, it's going to lead to like a loss of service for the other LD feeders. So that's what the short time withstand is really all about, and how we use it in electrical system design. And then we have the miniature circuit breakers, which are the smaller circuit breaker, mostly used in the branch circuit. And then the fourth one is the supplementary protectors, which are used as a backup protection. So you cannot use the supplementary protectors as a standalone device. You have to have a branch circuit protection, a UL 489 breaker at the upstream. And so where you find the application of a supplementary protector is mostly in control circuit, where you, industrial control circuit, maybe you're trying to protect a control transformer, for example. So those are the place applications where you find those type of miniature circuit breaker, the supplementary protector. And now I'm going to talk about our offerings when it comes to the circuit breaker. So the first one is a UL 489 miniature circuit breaker. We have 5 series here, different ratings. We have ones that are dedicated to DC alone. So that would be the B1B and the B1D. They are fully DC, and we use them in the renewable energy sector, while the other ones here, B1H, B1N, B1NQ, are all both AC and DC rated. So you can use them in those type of application. So it's let me just mention the key features here. So you have the contact position indicator. I've mentioned that before, and that's this portion here in the circuit, in the miniature circuit breaker, which tells you the status of the breaker. Basically tells you whether it's on or it is off. They're all DIN rail mountable. It's also a trip-free design, which is a fail-safe, which is a fail-safe design that ensures that even when the breaker toggle is stopped in the on position, if there is a fault, it ensures that you get a trip on the breaker regardless of the position of the toggle. And of course, all of our circuit breakers are all UL 489 listed, also CSA certified for the Canadian market. We also have the UL 1077 supplementary protectors, which like I said before, they are backup protective device, so they're not meant to be used as a standalone. You have to have a branch circuit breaker upstream of the supplementary protector. So we've got the AC DC type, and also the fully DC type, which is the EX9 BP. These products are UL 1077 recognized, both for the US and the Canadian market. In terms of the features, it's the same with the UL 489 type. So it's got the trip-free design, DIN rail mountable, and also the contact position indicator. In terms of the accessories, we've got all of these accessories available. I mentioned earlier on the part of your selection parameters, checking to be sure that the circuit breaker you're buying has got the ability to use accessories. So you've got all these electrical accessories, mechanical accessories, auxiliary and alarm switch, the shunt and under voltage, the front mount clips, the padlock, soffit mount. Also, we've got the bus bar system for the circuit breaker. So this basically eliminates the need to do a huge amount of wiring, because you can just use a bus bar, and then this gives you a plug and play kind of device, and it allows you to do a quicker installation for the circuit breaker. The shunt and the under voltage are examples of accessories. You typically want to use a shunt when you're trying to remotely open up the breaker. right? And also an under voltage is just a way of protecting the breaker from under voltage situation. So if you have an under voltage situation, it prevents the breaker from closing. So I'm moving on to the UL489 molded case circuit breaker. We've got quite a number of series here, and I'm just going to touch on them briefly. So we've got our traditional EX9 series, M1 to M6, goes up to 1200 amps, 6 frame sizes. We've got operational voltage up to 690 volts, and for DC rating, we can do 600 volts, but it has to be wired in series. Then we've also released 800 volt breakers, like last year, and the reason is because in the renewable energies market, we find out that more and more applications are having, in order for them to be able to drive more efficiency, so the voltage are going higher, and so you need devices that are rated up to 800 volt, 1000 volts. So this is an example of our response to those kind of customer need. So we've got this up to 400 amps at 800 volts and available in 3 poles. We also have the UL489 molded case switches and molded case circuit protectors. A molded case switch is just a circuit breaker without the protection functionality. So it's just a disconnect switch that allows you to be able to make, carry, and break the circuit under normal condition, and it cannot do that under an abnormal condition. The molded case protector is it's a device that is used for motor starting, and so it only has a magnetic protection, so only for short circuit, and cannot do overload protection. So again, just to say that, like I said, we've seen a lot of feedback in the renewable energies market. So we've got this DC breakers. This is rated up to 1000 volt DC, while the one on the right is 1500 volt DC. Again, because of the efficiency, the need for efficiency for inverters in the renewable energies market, we're finding a lot of application that requires this kind of DC voltage, and so we have this product also available for that purpose. These are the accessories in a like summarized accessories, because we have way more than this, but basically you can see the shunt and the under voltage, the multi-wire terminal log kits, conversion kits that allows you to convert from a log terminal to a bus bar connection. We also have rotary handles, flange handle as well. And also, we did mention earlier on that we have enclosed breakers. Today, we can go up to 1200 amps enclosed breakers in type 1, 12, and 3-hour enclosures for up to 600 amps. And then for the 1200 amps, we do type 1 and type 3-hour. And that's one of the things we do in our mod center in both in Canada and in the US. So and we've seen a lot of good opportunities because of this. So and our enclosed breakers are service entry rated. So it's a service entry equipment, meaning that you can use it for your service entry for the utility, and it can also be used anywhere else in the system. You just have to comply with the requirement for the service entry if it's at the service entry level. And then the third group of products that I would talk about today is the power circuit breaker. We have 3 families here, the A25, A32, and A40, and all rated at 800 volts and fixed and draw out. So and so these are all these are flagship products from NOARK, and because of our mod center, like Rob said earlier on, we are able to quickly configure an ACB and ship out from our mod center in California. So this power circuit breaker, they are also available as disconnect switch up to 4000 amps, and they have a number of accessories here, which I will not go into a lot of details, but I would like to kind of talk about the energy limiting maintenance switch. So I mentioned earlier on that sometimes you can have the occurrence of arc, whether through a normal operation or as a result of a fault. So when you have those arc, the NEC requirement is that you must have a way of quickly telling the breaker to not wait for any delay, any preset delay, and quickly react to the fault. And when it does that, it's going to reduce the amount of electrical energy that can flow in your system. So we do that using the ELM10, the energy limiting maintenance switch, which is a device that you have here, number 13. So that's an important device, and we have it for the 1200 amps enclosed breaker and also the power circuit breaker. The other important accessory here is the trip unit, obviously. So that's what gives you the protection. So we've got them in the LI, LSI, LSIG. We have the basic trip unit. We've got the ammeter, and also we've got the advanced one, which we call the harmonics type. That allows you to measure the current, the voltage. You can, also monitor the harmonics in the systems as well. So that's in a nutshell what we are able to offer as NOARK. So I'm going to at this point hand over to Karen as she talks about the real life application for our circuit breakers.
Thank you, Kumni, and thank you, Rob, and all the NOARK's team for inviting me here. So my name is Karianne Saint-Amour. I'm the Vice President at STA Boxes. So our company was founded in 2011 following a customer request for a 600M load bank connection box. So after 15 years, we're still expanding in the domain. And we have also won the MCEE Shows Award for New Product in 2013. Next slide, please, Cindy. So what is STA boxes? It would be a permanently installed boxes designed for temporary connections. So we use the CAMLA connector as oversized power outlet to connect generators or load bank or even event equipment. So they're really easy to use, weatherproof, and resistant to cold temperature. Also, our enclosure integrate NOARK's components, such as molded case circuit breakers. So they are available in various amperage, voltage, short circuit current rating. And these enclosures add safety to our installation, and they help prevent dangerous setups, such as using alligator clips or booster clamps. We see it a lot in temporary installation. And we also love the service with NOARK. It's really the fast delivery, and we love that they offer a 5-year warranty. So it demonstrates that they have a long-term reliability and peace of mind for any temporary power connections. Next slide. Thank you. So STA boxes can be installed outside or inside. They have different finish available, so like stainless steel, steel painted gray, aluminum. The circuit breaker had a security during the load bank test. So when the breaker is on position off, there is no more power at the CAMLA connector. And also our design offer like a double door, so there's no possibility to disconnect the connector during a test. So that is very important for us. We use also the pilot lights from NOARK. For our phase rotation detector, this option allows you to verify the building phase rotation before powering up. It helps prevent reverse pump rotation and potential equipment damage. Next slide. Thank you. So during the COVID pandemic, there was a market shortage for fuse disconnect switches. So a wildlife park, the name is Park Omega. So they reached out to us and they wanted to verify what we could do for them to open their new lodging unit for wolf observation. So thanks to NOARK's product and our expertise, we designed a new enclosure with circuit breaker inside for each unit, which allowed them to open on time. So we're really happy of this project. Quick connection and closure with CAMLOC are often used in the public sector also. So like school, community center, fire station, police station, hospitals, all these facilities require a quick connection solution in the event of a power outage. That's where our STA boxes come in play. It's a secure and a user-friendly quick connection design to perform reliability event at -30 degrees Celsius in the harshest condition, including severe ice storm. Next slide, please. Thank you. So we can say that NOARK and STA boxes are two companies committed to safety, reliability, and quality, focus on rigorous control and verification process to ensure maximum user protection. There's also Canadian regulation have recently changed for building equipped with elevators. Annual load bank testing is now mandatory. So we recommend to use the STA boxes to make testing easier. Also, all our products are CSA certified, and we are also approved with the Hydro-Quebec as the main switch manufacturer. So thank you so much for me being here today.
Thank you, Carrie-Anne, for that fantastic presentation and walking us through some of those interesting things that you guys do in that rather neat project, which I'm sure was fun and presented some interesting challenges in a wildlife setting. We have had a number of questions come in as we've moved forward, so I will ask those as we go. And Carrie-Anne, Kunmi, or Rob, feel free to jump in, whoever is the best to take on that and tackle that question. The first one we had actually was related to a bit of cost analysis, so I'm not sure, maybe Rob is the one for that, but we had a question that was regarding when you were going through the UL 489 breakers and the UL 1077. No, the individual has asked if you could go into some details on why the UL 1077 breakers tend to be substantially more expensive than UL 489, and what is it about the UL 1077 that makes it cost more?
Okay. Yeah, I'm not sure where you got that data from, but our 1077 is not more expensive than the UL 489. So if you look at our UL 489, they are 10 KA, they are 10,000 amps. So the KIC, the interrupting rating is 10,000, 10 KA, while for the 1077 it's 6 KA. So and that's an important parameter when you're looking at the design and the cost for the circuit breaker, the interrupting rating. Because the higher the interrupting rating, the higher the quality of the contacts, because the contacts in the circuit breaker are made of special metal alloys, right? So if you want to get a better interrupting rating, so then the quality of that special metal alloy has to be more, and of course that's where the costing come into place.
Perfect. Thanks, Kumi. I actually was pointed out the individual that I actually asked that backwards. They were looking at why the 489 was a more expensive, but I think your metal explanation probably aligns that up quite well. In following along with some of that, when you were going through the molded case circuit breaker, I had a question on why the molded case has both thermal mag or electronic trip, whereas the others only offered one or the other.
Okay, so for us, for our miniature circuit breaker, it's only a thermal mag. But of course, it's the possibilities are limitless. You can also have electronic type of a miniature circuit breaker, but the one we offer right now is thermal mag only. And then for the molded case, we've got both electronic option and also the thermal mag.
Perfect. Thank you for that. Rob, this one's a little bit more, I think, on your side of it. And it's a bit more of a generalized question, but being the director of R&D, and you talked about some of the things you guys are looking at and moving towards. When you're looking at what you're going to put R&D into, what is sort of the process, and how do you assess where to focus your R&D efforts? Is it a mix of customer input, shifts in the market? Can you just speak a bit to the direction of your R&D and what influences it?
Sure. So really, it starts with a marketing analysis of a couple things: the market opportunity and the marketing strategy that we're putting in place. So those are the primary drivers of the R&D programs that we put in place. And I will say that the latest sort of geopolitical factors that have come from the Trump administration have caused us to take a look at what is that strategy. And even before that came into play, we had already recognized that our growth should really be not just in component products, but also in what we call low voltage assemblies. So this is panel boards, switchboards, expanding beyond the enclosed breakers that we already have. So that's what I would say is sort of the major strategic focus for us going forward through the balance of this year.
No, thank you for that. Question just came in on what communication protocols do your circuit breakers support? Like Modbus, TCP?
Yeah. So I'll take that one. So the breakers typically come with RS-485 Modbus protocols. We do have some gateway products that will do some translation, but the native protocol for the breakers is RS-485 with Modbus.
Okay. Yeah, absolutely. Appreciate that. I have a question. Some people here may be aware that we did this in French earlier this week as well. And one of the questions that came up was from a piece of terminology that was used. And Kunmi, you spoke quite a bit about the ARCs and how that works. With regards to that, one of the wordings that came across earlier this week were arc extinguishing. And there's been so many words about arc extinguishing, arc quenching, arc mitigation. Could you just explain a little bit about the arc extinguishing and what exactly that terminology and how it fits with your breakers?
Okay, yeah, so like I said before, in the process of the contact of the circuit breakers separating, like moving apart, remember you're dealing with voltage here and current. So it's almost like where you have I'm trying to look for another kind of example. So maybe like a pipe in the water, right? So there's pressure. That pressure is like, that's the voltage, right? And then you have the water flowing in the pipe, that's the current. So the moment you try to separate the contacts of the circuit breaker, you're gonna have a situation where the air around the contact, the air, right, surrounding the contact is going to be turned into a conductive part for the current. So, and it's a momentary thing because of the voltage involved, right? The voltage involved and the current. So it's a momentary thing where the air is ionized, so it turns into a conductive part for the current, and that ionization is what causes those, it generates this light, like a flash kind of thing, and it also generates heat. And that arc itself needs to be contained. It needs to be extinguished, or like, so it needs to be kind of removed from the circuit breaker itself. One thing is that the contacts are designed to withstand the arc, right? So, and then also to dissipate it, to break it up into smaller arcs, and then safely are dissipated away. So that's the extinguishing that we are talking about here.
Perfect, thank you. Carrie-Ann, this one actually may be for you. Could you give a little bit more detail about like the safety offered, or you know, the primary purpose and goal behind the double door that you mentioned when you were talking about the application that you guys put in?
Yeah, so mostly the security is really our main goal. It's really important that every connection has to be really secure. So that's why we put a double door, so to make sure that when the disconnect, the circuit breaker is in position on, so there's no possibility to open the door and access to the cam lock. So there's no way to disconnect any connector when they are operating at the same time.
Very interesting. And just while I have you, I mean, I'm going to ask you my own personal question here. Do you have any interesting stories from working in that wildlife setting, or you know, having worked in the, you know, a unique thing? What were some of the challenges that were posed from such a unique setting?
Well, yeah, we do have really people that inside our enterprise that are really good with technical, and we make sure to always respect the need of the client. Sometimes we do also custom made because they have rare small spaces, or they don't have enough space, so we can do custom, but our main goal is always to make sure that the customer have everything they need. So yes, this one was really good project for the Parc Omega. It's every little like a lodge, so you can see the wolf, and so there's a breaker that can close each of the lodge independently. So it's better if there's a power outage, or if there's like a misfunction for electrical, so they just close the breaker for this particular lodge. So that's why it's good. But we work on other very good projects, like big hospitals, or a lot of like pumping station, or new data center, or yeah, new big centers. Yes.
Oh, that's very, very great. Yeah, no, clearly, you guys are doing quite a bit, and you know, congrats on that product win at the MCE as well. Great
Thank you,
showing
Paul.
this year. So admittedly, the last question that I came in was really quite a general one that we have focused on. So I mean, I admittedly, you know, obviously it's just a focus on, you know, really what is the primary things that set NOARK apart. I know you guys have gone through that a lot with your offering, the mod center abilities. You know, Carrie-Ann spoke a lot to how NOARK was there and their warranty support. So so really at this point, if Kunmi or Rob, if you want to make any last final notes on what sets NOARK apart, that will probably be what wraps us up today.
Yeah, I can speak to that. And it really comes back to the tagline at the end of my presentation. It's excellent products and exceptional value. In my opinion, you know, what makes us different, and as a new entrant to the market, it's important, is that we're offering world-class products that are easily available here in the market. And you know, that's really the value that we bring. We're bringing very high quality products and making a difference in terms of availability and service in the market.
Perfect. Really appreciate that. And I think that's spot on. So, you know, just the last couple comments that have come in have just been thanking you all for taking the time to provide your expertise and go through all of this. And yes, again, we will be providing a recording of this webinar, so everybody will be able to gain access back to this. And then just so you all know, I've even had a few people ask for contact after the fact. So you'll have some follow-up to do. You know, with that, I will say, you know, thank you so much to Rob, Kunmi, and Carrie-Ann, and for everyone that joined us today. And hope everyone has a fantastic rest of their day. And we will follow up, as you can see there, with in our post webinar, and there will be a draw for those who have attended today. So good luck to everyone, and hopefully we are reaching out to you as the winner. Have a great day, and we'll talk to you all later.